starting with a new topic that's basically under the heading of electrolysis, which is the selective discharge of ions in electrolysis. Now, to recap, if you remember that anions, they would go to the basically the positive electrode that's known as the cathode, the anode, while the cations that are the positive ions, they will be going to the negative electrode that's the cathode. So what happens is that last time we were discussing about an example in which I said that if I have an electrolyte which is basically concentrated sodium chloride, and that's basically aqueous, which means that you have water into it. So due to this, you would be having two types of ions. So what are those two types of ions that you would be having?
Okay.
So what would be the two cations and the anions?
Two cations and two anions.
Yes. Remember that
Uh,
aqueous means water.
oh yeah, okay, okay, and one sodium.
Very good. So yes, cation is going to be sodium.
Fuck. Yeah,
And what else? The second one?
water.
Okay, good. So you're right. So the second cation is going to come from the water, which is basically the H positive ion. That's the cation. And then you have a hydroxide ion. That's going to be the anion that will be coming from the water. So let's now write over here chloride and then OH negative. Okay, now what happens is that you see you have two types of cations that are going to go to this, cathode, and then you have the two types of anions that will be going to the anode. Now over here, the question is that out of these two and out of these two, which one of them is going to be discharged, or which one of them is going to be deposited on the electrode, and which one of them is going to stay as the ion. Now so there are basically three rules for this. One is, you can say, for the cations, we will be discussing the reactivity series for that. The second,
Can you repeat the question, please? Can you
uh,
repeat the question?
no, I
Because
was, uh-huh.
because I'm trying to understand what you're explaining, but I didn't get the question properly.
Okay, let me then tell that. Let me repeat this again. So I was saying that, first of all, you see that over here at this, let's just draw it over here. This is our anode and this is our cathode in this, electrolysis chamber.
Okay.
And the electrolyte over here is the concentrated sodium chloride aqueous. So I said that at the this cathode, you would be having the two ions that are going to be attracted to it. Which are those two ions?
Sodium and H plus.
Absolutely right, very good. And then which are those two ions that will go to the anode?
Ci minus or H minus.
Absolutely right. Now, the question over here is that, well, like, let's first talk about these anions. Well, chloride, is going to be it's going to be oxidized on this anode and form the chlorine gas, or the hydroxide ion is going to be preferred and it will form oxygen at the anode. So it's basically a competition between the two ions, that which one of them is going to be oxidized over here. So the choice is that either one of one of these two is going to be oxidized and the other one is going to stay as this negative ion. So now we have to decide that.
Okay.
I hope it's clear.
Yeah, yeah.
And similarly at the cathode as well, there are two cations that are migrating over there. So again, which one of them is going to form a neutral atom, and which one of them is going to stay as a positive ion? So to solve this, you can say, mystery, we have three you can say ways, or three, you can say, theoretical or empirical things that will help us to decide this.
All right.
So what are those? So those are basically related to, first of all, the cations. So there is for the cations there is this reactivity series according to which we will follow that. And for the anions, there is also, you can say, a trend that you will see. And then the third thing is basically the concentration of anions. So today, we will be discussing these.
All right.
Okay, so first of all, if you remember yesterday, we wrote a reactivity series for the metals, for the cations basically, which was something like this. Just let's write it together. So we said that the most reactive, element is going to come at the top. That's going to be potassium. Then you have sodium. Then you have lithium, and then you have calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, and then you can have silver, and then you have gold. So this, the series that I wrote just now is the reactivity series of the metals, in which the potassium is basically the most reactive metal, and the gold is the least reactive of them.
All right.
Okay, now what happens is that what what you can see, the basic property of metals is that they, the most reactive metal likes to stay as an ion, as a positive ion, because when metals react, they lose their electrons. So that is why we say that the more reactive a metal, it's going to prefer to stay as a positive ion. Like, let's suppose if we have potassium, so when it's going to lose one electron, it is going to like to be staying in this positive cationic state. Is this point clear?
Yeah, miss.
And if we talk about the, the gold over here, so if gold again loses one electron and becomes a cation, it does not like to be an ion. So whenever it forms an ion, it will always find a chance to get a to get back to a neutral atomic state. And how it will do that? It will do that by gaining electron or by getting reduced. So now let's go back to the concept that, we said that at the cathode, the negative, electrode, the positive cation is going to go, which, has this positive charge. And if you remember, we said that it gains one electron and forms a neutral atom, which is known as the reduction reaction. Do you remember this? The gain of
Yeah.
electrons? Okay, good.
Yeah.
So now what happens is that more the more metal is reactive, it's going to it will prefer to stay as an ion. Let's write it this way. And let's write then over here that the if the metal is least reactive, it does not like to stay as an ion, prefer to stay, hence it would like to get reduced. I'm writing it here, reduced. Okay, now what happens is that if, over here we are talking about sodium and hydrogen. So let's now locate the sodium and hydrogen in the reactivity series. So sodium is somewhere over here, right?
Yeah.
And hydrogen is somewhere over here. So if you see, sodium is more reactive than hydrogen, right?
Yeah.
So this would mean that sodium would prefer to stay as an ion, and it will not go and reduce itself at the cathode, while the hydrogen is going to get reduced at the cathode because it does not like to stay as an ion. So that is why out of sodium and the hydrogen ion is going to get reduced, while the sodium is going to stay as this positive ion in this electrolyte, and nothing will happen to it. So what will we see? We will see that hydrogen gas is going to be released at this cathode.
Right.
I hope it's clear.
Yeah, a bit.
Okay, so let me explain this again. Let me just scroll down. Okay, now let's repeat the concept. We said that sodium is more reactive, while
So it's
hydrogen.
preferred ion, and
Exactly.
hydrogen is preferred to reduce because it has lower ions. And yeah, and yeah, that's what I know.
Mhm. Yes, very good. You're right. You can try. And what about sodium?
Sodium is more reactive and is preferred to stay as an ion. Hydrogen is less reactive,
Mhm.
and you can change it from an ion.
Exactly. You're absolutely right. So very good. You have, understood the concept correctly.
All
Oh,
right.
okay. Just give me